Hello everyone. In this video we will see empirical and molecular formula. Let's define first of all what they are. So the formula which shows the simple whole number ratio of atoms in a compound is known as empirical formula, while the formula which shows the actual ratio of the atoms in a compound is the molecular formula. For example, we got a compound glucose. The formula of glucose is C6H12O6. This is the molecular formula. So if you take the simple whole number ratio of this of the atoms in it, so what we'll get? We get CH2O. So this will be the simple whole number ratio of the atoms, and this formula CH2O is the empirical formula of glucose. Similarly, we can have a formula like C2H6. This is the formula of ethane. So if you represent the simple whole number ratio, what it would be? It would be CH3. CH3 is the empirical formula of ethane. Similarly, we can have a compound like C2H4. This one is ethene. Simple whole number ratio, it would be CH2. So from any given formula, like you got H2O2 is the formula of hydrogen peroxide, it's the molecular formula. The empirical formula will be HO. So from any given molecular formula, we can find the empirical formula by just taking the simple whole number ratio. But there are compounds in which the simple whole number ratio is not possible. For example, we got water. So the molecular formula of water is H2O. Empirical formula will also be the same H2O because there is no simple ratio possible. Then let's say we got a compound that is H2SO4. In this compound, it's the molecular formula, but there is no simple ratio possible. So the same will be the empirical formula. So we have seen how to find the empirical formula from the given molecular formula. Now let's see how to find empirical formula from any given structure. So look at this first structure in which we got phosphorus and oxygen. So if you count the phosphorus, they are 4 in number, while if you count oxygen, they are 6. So the molecular formula for this compound is P4O6. And if you find the simple ratio, that would be P2O3. So in this way, we can find the empirical and molecular formula from the structure. Let's have more examples. So the next structure we got is this, in which we got chromium, carbon and oxygen. So you see in the center there is one chromium, so you'll say there is Cr, and there are 6 carbons, so C6, and there are 6 oxygens, so there are O6. So that is simply the empirical formula of this compound. So next we got this structure of silicon carbide, and we have to find its formula with the help of the structure. So you see there are white dots, they are carbon, and if you count these carbon atoms, you find that they are in total 19. Similarly, if you count silicon, you'll also find them the same, that is 19. So since we have to find silicon carbide, it should be Si, and there is 1:1, so write SiC should be the formula of this compound silicon carbide. So in this way we can find the empirical and molecular formula of a compound from its structure. Now let's move ahead and see how can we find the empirical formula from the percentages of the elements given. Let's solve some questions. So look at this question in which we got carbon, hydrogen and oxygen, and their percentage by mass is given, and we have to find the empirical formula. So how do we find this? The first step is to write the elements, like we got carbon here, hydrogen and oxygen. Then what we will do, that these percentages that we are given with, the first step is to divide these percentages with the atomic masses of these elements. Carbon, is 12, so divide by 12. Hydrogen is 1, oxygen is 16. So first of all, we will divide the given percentages with their atomic masses. So the carbon, it would be 6.38. It would be 6.38, and let's see this. So we will get 1.064. Now, the next thing. In the first step, we have divided the given percentages with the atomic mass of the elements. The next step is to divide all of these numbers that we have got with the smallest number. So in these three numbers, the smallest number is 1.064. So you'll divide all of them with this. So we got 5.996 for carbon. So we can round it to 6. Similarly, it can be rounded to 6 and we get 1 for this. So the empirical formula, it would be C6H6 and O. So this is how you find the empirical formula. In the step 1, we have divided the percentages with the atomic masses. Remember, in the first step, the values that you got, don't try to round these values. Try to use at least 3 decimal place values so you will not have wrong answers. Fine. And then when you divide in the second step with the smallest number, you can round the numbers, like you got 5.99, you can make it 6. Okay, so it's like this. Let's see some more questions. So look at this question in which an organic compound has a molecular formula, this one. What is the empirical formula? You can see the simple ratio, it's 8, 16 and 4. So it would be 2 ratio 4 ratio 1. Okay, 2 4 1. The 2 4 1 is A. Fine. So this is how you can find the empirical formula from a molecular formula. So let's see this MCQ in which we got a compound containing only carbon and hydrogen while 80% is carbon. So we have to find the empirical formula. That means we got carbon, that is 80%, while hydrogen, definitely it would be 20%. So divide both of them with their atomic masses. Okay. So for carbon it would be 6.66, while hydrogen, definitely it's 20. So divide both of them with the smallest number, that is 6.6. So dividing here with 6.66, dividing here with 6.66. So we get 1 over here and 3 over here. So the formula, it would be CH3. B is the answer. So look at the next question in which we got 70% by mass of iron and 30% by mass of oxygen, and we have to find the empirical formula. So let's write this, that we got Fe, it is 70% and oxygen is 30%. So divide both with their atomic masses, 56 and 16. So we'll get 1.25 and 1.875. Next is dividing the both with smallest number. We get dividing with 1.25 divided by 1.25. So it would be 1, and so we get 1.5 over here. Now we don't get the complete numbers that we can write below the symbols to make the formula. Sometimes this happens that after the division with the smallest number, you don't get the whole numbers. Now in this case, sometimes you get 1.33, sometimes it may be 1.25 or 1.5. So what we have to do here, that we have to make this number 1.5 the complete whole number. And how we can do this? We can multiply this number with such a number that it becomes a complete number. So we can multiply actually both of them. We have to multiply by 2. So times 2 will make it 2 and it will become 3. Now we get the complete figures. So the formula will be Fe2O3. The answer would be B in this case. Now let's see how to find the molecular formula from the empirical formula. Molecular formula, for example, we got the molecular formula of glucose, that is C6H12O6. Its empirical formula would be simple whole number ratio, that is CH2O. So if you look at carefully the empirical formula, you can see that you need to make it times 6 to get the molecular formula. So if you multiply the empirical formula by 6, you will get the molecular formula in this case. But it's not always the case. Let's see. We got a compound whose molecular formula is C2H4 and its empirical formula, it will be CH2. So to convert this empirical formula into molecular formula, you need to multiply it by 2. So different compounds, they need a different number to convert the empirical formula into the molecular formula. Let's see another example. For example, we got C3H6. Its empirical formula will be CH2. So we need to multiply it by 3 to make it C3H6. So it can be concluded that different empirical formulas, they require a different number to be converted into the molecular formula. And how do we get this number from? If you look at the molecular masses of the molecular formula and the empirical formula, let's see this. For example, right now the glucose, its molecular mass Mr is 180, while that of this empirical formula, it is 30. So what we do, if we divide this 180 with 30, you will get the 6 that you will use to convert the empirical formula into the molecular formula. Similarly, over here, if you find the molecular formula of this, that would be 28, and it would be 14. So 28 over 14 will give you 2 that you can use to convert the empirical into the molecular. And again here we can get 36 plus 6 is 42, and it would be 12 plus 2, 14. So 42 divided by 14, that will give you 3. So the bottom line is that if the molecular mass is given, remember, whenever you have to find the molecular formula, the molecular mass is always given. Mr is always given. Okay, then you find the empirical formula by the way that we have just discussed, and then you'll find the empirical formula mass and divide the molecular mass with the empirical formula mass to get this value, and that you will multiply with this. So we can say that any empirical formula, it can be multiplied with a certain number and we can get a molecular formula. And where we get this n from? The n is obtained by dividing the molecular mass Mr over the empirical formula mass. So this is the way to find the molecular formula. Now let's do some questions. So let's see this question in which we got hydrogen, uh, that is 0.04 grams. Carbon is given 0.242 grams, and chlorine is given 0.718 grams. So let's divide with the atomic masses, divide by 1, divide by 12, and divided by 35.5. So it would be 0.04, it would be 0.02, and this would be again 0.02. So the smallest number that we have is 0.02. So divide all with 0.02. So we get 2, 1, 1. So the formula will be CH2Cl is the empirical formula. Now this is saying the relative molecular mass of the compound is 99. Find the molecular formula. So we have to first of all find the empirical formula mass. That will be 12 plus 1 times 2 plus 35.5. So that is 49.5. So next is to divide this 99 with 49.5. So that will give you 2. So now we can multiply this empirical formula with 2 to get the molecular formula. So that will be C2H4Cl2. So this is how first of all we'll find the empirical formula, then we'll find the empirical formula mass, divide the molecular mass with the empirical formula mass to get a number, and that number is multiplied with the empirical formula to get the molecular formula. Hope you got this all. So let's see the next one in which we got 40% carbon. So carbon is 40%, hydrogen is 6.7%, and oxygen is 53.3%. Divide all of them with their atomic masses. So it would be 3.33 is 6.7, and that is 3.3125. So divide all of them with smallest value, that is 3.3125. So that will be almost 1, it would be 2, and it would also be 1. So we got the empirical formula CH2O. Now they've said the relative molecular mass is between 55 and 65. So let's find the empirical formula mass and then we can decide. We got 12 plus 2 plus 16. So that is 30. It means that the molecular mass, it should be 60. So we can have the value of 2 from this. So 60 divided by 30 will give you a value of 2 that will multiply over here to get C2, H4 and O2. So the answer is C in this case. Let's see another question in which we got calcium, hydrogen, phosphorus and oxygen. And we have to find the empirical formula of this compound and we have to suggest the formula of the anion. Let's make the calculations. So first of all, we divided these numbers, the percentages, with the atomic masses of the elements, and then we have divided the smallest number to get the empirical formula, that is CaH4P2 and O8. Okay, so next they're asking that what is the formula of the anion. So if you look at this formula, that is CaH4P2O8. Now in this formula, this is cation and this whole is the anion. The calcium is in group number 2. That means it carries a charge of +2, and this whole, it should get a charge of 2 negative. But we can find a simple ratio of the elements in this anion, and that would be what? That would be H2PO4. And since we have made the numbers to half, the charge -2, it would be also -1. So the actual formula of this compound, it would be Ca bracket H2PO4 twice, and the formula of the anion, it would be H2PO4 1 negative. So this was all about the empirical and the molecular formula. In the upcoming videos, we will clarify more our chemistry concepts, and till then, goodbye.